This is John Black, Super Chemist. This is just a disclaimer to let you know that this video is not intended to be imitated. No parts of it should not be copied or done by you or anybody. It's just for educational and maybe entertainment purposes to watch. That's it. I don't condone anyone repeating anything in the video. Alright, here's the deal. This is the pot. This is what I got. This was the low boiling point stuff. I have to look at the bottom, see how there's very little. You should never smell chemicals. Yeah, it smells like aldehyde. I'm going to put my product into here with a stir bar and 20 grams of sodium hydroxide. And I'm going to stir it, hopefully get rid of the rest of the impurities. Hopefully it'll split up into two phases and I can put it in a soap funnel. But I doubt it. But I got a plan for that. I don't really see anything happening. I was hoping some red stuff would come out like it did when we used the acid. But we'll let it stir up. Put some cellophane over top. That sodium hydroxide was totally white. I don't know if you can see it, but it's yellow now. Yeah, you can't tell, but here maybe on the stove. Look at the stove background, and then see how yellow it is? That way it was perfectly white. So something's happening. So I'm gonna let that stir up for a while and see what happens. I don't know if you can see it on camera, but it's starting to turn it red now. See that red color by the magnet there? Watching I shake it turns yellow, but I don't see the red around the magnet. So it is it's polymerizing something and getting rid of it. That's good. And it's soaking up the water. Alright, so I let that stir for a couple hours. And I let it sit in this funnel for, I don't know, a half hour or something like that. It's still like, it's orange now. But I'm going to distill it again, so don't start getting stuck there. I'm going to have to filter that out. Alright, so here it is. It's orange as heck. I'm going to put some, and by the way, when I use the sodium hydroxide, if you use potassium hydroxide, it will always turn biphasic. Sometimes it doesn't if you use sodium like I did. I just got lucky. But an idea is if it doesn't, throw some, and you don't have potassium hydroxide, throw some potassium carbonate in. It might do the job. I'm going to put that on the stir bar, put it on stir it for a while, and then I'm going to go to distill that again, and hopefully it'll be clear by then. Put a tablespoon, half a tablespoon of each. Potassium carbonate, damp rid, which is calcium chloride, and sodium hydroxide. You can see it's got some more red stuff in there. So what I think I'm going to do is get that red stuff out of there, put some more sodium hydroxide in there, and let it sit overnight. Well, after an hour or so, I was like, screw it, it's not turning red. So I threw it in there. We got a bigger X column. It's already started to come over. Right now it's coming over at the proper temperature. Oh, there you go. That's what I got. It's nice and crystal clear. I don't know how much I weigh, but we're going to see right now. I got almost 75 milliliters there. So it's a crappy yield. But it is crystal clear, and I need it to make alcohol. So equation for it, you need 2 of the antifreeze molecules for every 1 dioxane molecule you make. Sulfuric acid is a catalyst, as we said. Usually that means 10% of whatever you are protonating. Here's your molar weights, or your molar milliliters: 58.8, 53.3, 85.3. This is the only one that doubles. Everyone else has just 1. Well, this is a catalyst. So I times this by 2 and I get 116 or 111.6. I used 150 milliliters. There was a reason why I used an oddball amount like that. You know, I like to use like molar amounts or fractions of molar amounts. That's all I had. And my cars broke down and I can't go get no more or whatever. So I was like, I got this little cup full. I might as well just do something with it. So that is 1.34 times the amount that we needed for this equation, right? 1.34 times this, 111 gives you 150 milliliters. So I took the dioxane and I times it by 1.34, right? And that tells me my theoretical yield should be 114 milliliters. I got a crappy 75. But for the first time I did it, 66% yield wasn't bad, I guess. Plus, when it was real tarry, most people, I think, they go through that tar until they're really scared that that tar is gonna foam up and go into the cold condenser and break it. You know what I mean? As soon as it even thought about moving up, I stopped. You know what I mean? So I'm sure that hurt my yield. Alright, the reason I used the amount of acid I did, that's the molar mass. I divided it by 0.95 because I have 95% sulfuric acid. Well, I should use anhydrous as much as possible. So that gives me 56. I times that by 1.34 that I got down from here. And that gives me 75 milliliters. But remember, it's only a catalyst, so I mean 10% would be, a start out point. So I took 10% of that, and it came out to 7.5 milliliters. Of course, this is a dehydration reaction, so the more, I got to soak up this water as it comes off, right? It'll push the equilibrium, but it'll go back. You don't want your water going back onto the alcohol. So if I double it, it'd be 15 milliliters. And I figured, well, I'll throw a little bit more, make it 20 milliliters. Can't hurt. And that's basically it. And always remember, science is great.